A cosmic puzzle. What's the flatness problem? This question has puzzled scientists and astrophysicists for decades, leading to some of the most intriguing theories about the nature of our universe. Imagine a perfectly flat piece of paper. Simple, right? But what if I told you that this simple concept holds the key to understanding the very fabric of our cosmos? That's kind of like what our universe seems to be, flat, not in the everyday sense, but in a way that defies our usual understanding of shapes and dimensions. Not flat like a pancake, but flat in a different way. A way that has to do with space and time. This flatness is a fundamental aspect of how our universe operates. This flatness is about how space-time behaves on the largest scales, how light travels, and how gravity works. It's a concept that influences everything from the path of a photon to the structure of galaxies. The weird thing is, according to Einstein's theories, the universe shouldn't be this flat. His equations suggest a universe that curves and bends under the influence of mass and energy. It should be curved, either positively like a sphere or negatively like a saddle. These curvatures would create a universe that looks very different from the one we observe. The fact that it's not, that it's incredibly close to perfectly flat, is what we call the flatness problem. This near-perfect flatness raises questions about the initial conditions of the universe and the forces that shaped it. Scientists have proposed various theories to explain this, including the idea of cosmic inflation, a rapid expansion of the universe just after the Big Bang. This theory suggests that inflation stretched the universe so much that any initial curvature would appear flat to us now. Understanding the flatness problem is crucial for our comprehension of the universe's origins and its ultimate fate. It challenges our perceptions and pushes the boundaries of modern physics. So, the next time you look up at the night sky, remember that the universe's flatness is one of its greatest mysteries, a puzzle that continues to inspire and challenge the brightest minds in science. The universe's balancing act, not too much, not too little. The cosmos is a delicate dance of forces, a grand symphony of balance and harmony. Think of it like this. Imagine trying to balance a pencil perfectly on its tip. It's a task that requires precision and patience. It's really hard to do, right? The slightest movement, the tiniest breath of air, and the pencil topples over. The slightest nudge and it falls over. This is because the pencil is in a state of unstable equilibrium, where even the smallest disturbance can cause it to lose balance. The universe is kind of like that pencil. It exists in a state of delicate balance, where the forces of gravity and expansion are perfectly tuned. If it had just a tiny bit more stuff in it, its gravity would have made it curve in on itself like a sphere. This would have led to a universe that collapsed under its own weight, forming a massive black hole. A tiny bit less, and it would have curved outward like a saddle. This would have resulted in a universe that expanded too quickly, spreading out so thin that stars and galaxies could never form. But it didn't. It's almost as if someone carefully balanced the universe perfectly on its tip, and it's been staying that way ever since. This perfect balance has allowed stars to shine, planets to form, and life to flourish. The universe's ability to maintain this equilibrium is a testament to the intricate and precise nature of the cosmos. Picture this, visualizing the flatness problem. The flatness problem is a fascinating concept in cosmology that deals with the shape and geometry of our universe. To understand it better, let's dive into a simple analogy. Imagine a balloon with dots drawn on it. These dots represent galaxies scattered throughout the universe. As you inflate the balloon, the dots move further apart. This is similar to how galaxies move away from each other as the universe expands. That's kind of like what's happening to our universe. It's expanding. The space between galaxies is stretching, causing them to drift apart over time. Now imagine drawing a triangle on that expanding balloon. The shape and angles of this triangle can tell us a lot about the geometry of the universe. If the balloon is perfectly spherical, the angles of the triangle will add up to more than 180 degrees. This indicates a positively curved universe, much like the surface of a sphere. If it's curved inward like a saddle, the angles will add up to less than 180 degrees. This represents a negatively curved universe similar to a saddle or a Pringle chip. But if the balloon is perfectly flat, the angles will add up to exactly 180 degrees, just like we observe in our universe. This flatness suggests that our universe is very close to being geometrically flat, which is a significant observation in cosmology. Understanding this helps scientists explore the fundamental nature of the cosmos and its origins. Section 4, Inflation to the rescue? A possible explanation. So how did the universe get so flat? One idea is something called inflation. Imagine that right after the Big Bang, the universe went through a period of super fast expansion, much faster than it's expanding now. This would have smoothed out any initial curvature, kind of like ironing out wrinkles on a giant cosmic sheet. Inflation is a cool idea, but it's just one possible explanation. We still don't know for sure why the universe is so flat. It's one of the biggest mysteries in cosmology. Section 5. The quest for answers, still a mystery. The flatness problem is a puzzle that has been bugging cosmologists for decades. It's a reminder that there's still so much we don't understand about the universe. Scientists are constantly searching for answers, using telescopes to study the cosmic microwave background radiation, the faint afterglow of the Big Bang, for clues about the early universe. Section 6. Why it matters, the shape of things to come. The shape of the universe isn't just an abstract concept. It tells us about the fundamental nature of space and time, the fate of the universe, and whether or not we're alone in the cosmos. Understanding the flatness problem could unlock some of the biggest secrets of the universe. It's a challenge that continues to inspire physicists and astronomers to push the boundaries of human knowledge.